Good afternoon, Doc. Good afternoon, classmates. I'm Alan Miasco, and today, my report is all about the table 8.4 on how to get the sample computation of Pearson product moment correlation coefficient between the weight and the length of milkfish cultured in the backyard fish pond using bread meal as supplemental feed. So if you have a book, you can follow me at page 202 to 203 for you to understand my report. So before we start, we will look back the report of Miss Unahan. So what is the correlation? Correlation is a measure to determine the degree of relationship of two sets of variables. So these are the x and y. These data are called the bivariate. They have two variables, the x and y, as measurement. So the correlation is very helpful for the teachers to determine the relationship of variables, the x and y, on how they are related with each other, whether it is very high relationship, or moderate relationship. Now, what is Pearson product moment correlation coefficient? So the Pearson product moment correlation coefficient is a linear correlation essential to determine the degree of relationship of two sets of variables, the x and y. So this is the most common measure of correlation to find the relationship of two sets of variables quantitatively. Now, we will look back in our table 8.4. So as you can see, there are 15 number of cases of milkfish, and they have different weight and length. So in our weight, it serves as our x, and the length serves as our y. So in our weight, these are the 0.6, 1.1, 0.5, 0.9, 0.7, 0.8, 0.55, 0.7, 0.6, 1.0, 1.2, 0.9, 0.8, 0.7, and the last is 0.53. And in our y, these are the 0.42, 0.61, 0.42, 0.58, 0.59, 0.5, 0.32, 0.5, 0.43, 0.61, 0.7, 0.51, 0.51, 0.45, and the last is 0.32. So now, the first step to do is to look for the sum of x and y. So we will going to sum up all our x and our y. So if we sum up our x, it will come up to 11.58. And our y, it will come up to 7.47. So now for the step 2, square all the x and y values to get the x squared and y squared. So we will square the x to get the x squared. So 0.6 squared is equals to 0.36, and 1.1 squared is 1.21. 0.5 squared is 0.25. 0.9 squared is 0.81. 0.7 squared is 0.49. 0.8 squared is 0.64. 0.55 squared is 0.3025. 0.7 squared is 0.49. 0.6 squared is 0.36. 1.0 squared is 1.0. 1.2 squared is 1.44. 0.9 squared is 0.81. 0.8 squared is 0.64. 0.7 squared is 0.49, 0.53 squared is 0.2809. So that is how we get our x squared. Now let's move on to y squared. So in our y squared, we will also square to our y. So 0.42 squared is 0.1764. 0.61 squared is 0.3721. 0.42 squared is 0.1764. 0.58 squared is 0.3364. 0.59 squared is 0.3481. 0.5 squared is 0.25. 0.32 squared is 0.1024. 0.5 squared is 0.25. 0.43 squared is 0.1849. 0.61 squared is 0.3721. 0.7 squared is 0.49. 0.51 squared is 0.2601. 0.51 squared is 0.2601. 0.45 squared is 0.2025. And the last is 0.32 squared is 0.1024. So that is how we get our y squared. So the step 3 is to sum all the x squared and y squared to get the summation of x squared and y squared. So we will sum up the x squared to get the summation of x squared. So this will come up to 9.5734. And our y squared, it will come up to 3.8839. Now, in our fourth step is multiply the x and y to get the xy. So now, we will multiply this x and y. So 0.6 times 0.42 is equals to 0.252. Then 1.1 times 0.61 is equals to 0.67 or 671. Then 0.5 times 0.42 is equals to 0.21. And 0.9 times 0.58 is equals to 0.522. 0.7 times 0.59 is equals to 0.413. 0.8 times 0.5 is equals to 0.4. Then 0.55 times 0.32 is equals to 0.176. 0.6 times 0.43 is equals to 0.258. And 1.0 times 0.61 is equals to 0.61. 1.2 times 0.7 is equals to 0.84. 0.9 times 0.51 is equals to 0.459. 0.8 times 0.51 is equals to 0.408. 0.7 times 0.45 is equals to 0.315. And the last is 0.53 times 0.32 is equals to 0.1696. Now, the fifth steps or step 5 is to look for the sum of xy to get the summation of xy. So we will total or sum up our xy and we will come up with 6.0536. So this is now our summation of xy. 6.0536. Okay, for the step 6 is you will get the correlation using this formula. So the correlation is equals to number of cases times summation of xy minus summation of x times summation of y over the square root of number of cases, the n, times summation of x squared minus submission of x to the power of 2 and times submission of y squared minus submission of y to the power of 2. So after that, we will all substitute all the numbers here in the given. So our n is 15. So times submission of xy is 6.0536. So copy minus submission of x is 11.58 times submission of y is 7.47 over, then you will copy the square. Now we will draw the bracket and substitute. So our n is 15 times submission of x squared is 9.5734. Then you will copy minus submission of x is 11.58 power of 2. Then bracket, we will draw bracket again. So our n is 15. Then submission of x squared is 3.8839. Copy minus submission of y is 7.47 to the power of 2. After we substitute all the numbers in the given, we will now multiply. So 15 times 6.0536 is equals to 90.804. Then you copy minus, and 11.58 times 7.47 is equals to 86.5026. Over, then you will copy the square. So 15 times 9.5734 is equals to 143.601. Then you'll copy minus. So 11.58 to the power of 2 is 134.0964. Then 15 times 3.8839 is equals to 58.2585. Then minus 7.47 to the power of 2 is equals to 55.8009. After that, we will subtract 90.804 minus 86.5026 is equals to 4.3014. Over, then you will copy the square. Then 143.601 minus 134.0964 is equals to 9.5046. Next, 58.2585 minus 55.8009 is equals to 2.45 8.76. Then we will multiply 9.5046 times 2.4576. So we'll copy first the 4.3014 over squared of 9.5046 times 2.4576 is equals to 23.358505. 23.358505. So after that, we will get the squared of 23.358505. So we will copy for 4.3014 over squared of 23.358505 is equals to 4.83306,373. So after we get the squared of 23.358505, we will now divide the 4.3014 divided by 4.83306,373, and we will get the correlation is equals to 0.889994. So our correlation now is equals to 0.889994. The correlation value is obtained is 0.88994, which denotes high relationship. Hence, the relationship between the weight and length of milkfish cultured backyard fish pan using bread meal as supplemental feed is high. This means the heavier the weight, the longer the length, and the lighter the weight, the shorter the length, or as the weight increases, the length also increases. Remember, in getting the interpretation of correlation, we should think the size of correlation. If the size of correlation is positive or negative 0.90 to 1.0, it means very high positive correlation or very high negative correlation. If the size of correlation is 0.70 to 0.90 positive or negative, the interpretation is high positive correlation or high negative correlation. If the size of correlation is positive or negative 0.50 to 0.70, it means moderate positive correlation or moderate negative correlation. If the size of correlation is positive or negative 0.30 to 0.50, it means low positive correlation or low negative correlation. And if the size of correlation is 0.00 to 0.30, positive or negative, it means negligible correlation. Now for you to understand my report, I have my own data here, the computation of Pearson product moment correlation coefficient between the age and glucose level of 10 diabetic patients in St. Elizabeth Hospital. So we have here the 10 subjects, and we have the age that serve as our X and the glucose level serve as our Y. So the age is 40, 45, 38, 50, 48, 61, 55, 47, 59, and 61. And our glucose level, the Y, is 98, 95, 80, 60, 75, 85, 74, 81, 77, and 63. Now for the first step to do is to look for the sum of x and y. So we will sum up all the x, and the total is 504, and our y, if we sum up the y, we can come up with the submission of y is equals to 788. Now for the step 2, squared all the x and y values to get the x squared and y squared. First, we will get the x squared first. So 40 squared is equals to 1600. 45 squared is 2025. 38 squared is 1444. 50 squared is 2500. 48 squared is 2304. 61 squared is 3721. 55 squared is 3025. 47 squared is 2209. 59 squared is 3481. 61 squared is 3721. Now, in our y squared, 98 squared is 9604. 95 squared is 9025. 80 squared is 6400. 60 squared is 3600. 75 squared is 5625. 85 squared is 7225. 74 squared is 5476. 81 squared is 6561. 77 squared is 5929. 63 squared is 3969. Now for the step 3, sum all the x squared and y squared to get the summation of x squared and y squared. So we will total the x squared, all the values of the x squared, and we will come up with 26,030. Then in our y squared, we will sum up, and we get the 63,414. Now for step 4, multiply the x and y to get the xy. So 40 times 98 is equals to 3,920. 45 times 95 is equals to 4,275. 38 times 80 is equals to 3,040. 50 times 60 is equals to 3,000. 48 times 75 is equals to 3,600. 61 times 85 is equals to 5,185. 55 times 74 is equals to 4,070. 47 times 81 is equals to 3,807. 59 times 77 is equals to 4,543. 61 times 63 is equals to 3,843. Now for step 5, look for the sum of xy to get summation of xy. So we will total all the numbers of xy, and we can come up with summation of xy is equals to 39,283. Now for the sixth step, solve for the correlation using this formula. So correlation is equals to number of cases times summation of xy minus summation of x times summation of y over the square root of number of cases and times summation of x squared minus summation of x to the power of 2 and number of cases and summation of y squared minus summation of y to the power of 2. So first step to do is we will substitute all the numbers here in the given. So our n is 10, summation of xy is 39,283, Summation of x is 504. Summation of y is 788. Summation of x squared is 26,030. Summation of y squared is 63,414. So now we will substitute all the numbers. Minus summation of x is equals to 504 times summation of y 788 over the squared of n is 10 times summation of x squared is 26,030 minus summation of x squared, summation of x rather, is 504 power of 2. Then 10 times summation of y squared, 63,414 minus summation of y to the power of 2 is 788 power of 2. After that, we will multiply all the numbers. So 10 times 39,283 is equals to 392,830. Next, we will copy minus 504 times 788 is equals to 397,152. So over the square of, so 10 times 26,030 is equals to 260,300. So I will copy minus, then 504 to the power of 2 is equals to 254,016. Next is 10 times 63,414 is equals to 634,140. So we'll copy minus. Next, 788 to the power of 2 is equals to 620,944. Okay, after that, we will subtract. So 392,830 minus 397,152 is equals to negative 4,322. Over square of 260,300 minus 254,016 is equals to 6,284. So we will 6,284. Then 634,140 minus 620,944 is equals to 13,196. Okay. After that, we will multiply 6,284 times 13,196. So we will just copy negative 4,322 over the square of. So 6,284 times 13,196 is equals to 82,923,664. After that, we will just copy the negative 4,322 over. Then we will get the squared of 82,923,664, and the answer is 9,106.24. Then we will divide negative 4,322 divided by 9,106.24 is equals to negative 0.4746 19601504. So the correlation is equals to negative 0.47461960015004. This is now the answer of the correlation of the computation of Pearson product moment correlation coefficient between the age and the glucose level of 10 diabetic patients in St. Elizabeth Hospital. So the correlation value obtained is negative 0.474619601504, which denotes low negative correlation. This means that the younger the ages, the more it will prone to diabetic. Or the person who have the high level of glucose is prone to diabetic is mostly in the people who has at the young age. So that's all my report. I hope you understand. Thank you and God bless.